Bob here, Chopper Bob Customs. Hey, thanks for watching my videos. Thanks for subscribing. If you haven't subscribed yet, please consider doing so. Thanks for liking the videos. If you got any comments, questions, be sure and put it in the comment section. If it's a question or if it's a comment that I need to address, I try to get back to those in a prompt fashion. And then set the notification bell because I'd hope to be a little bit more regular on getting these posted. As I've said in another video, we've had some family medical issues that aren't severe, but they do require some time and attention. My camcorder also gave up the ghost. So right now I'm using my phone. I'm getting used to that. I'm trying to decide whether I want to get my camcorder fixed or whether I want to get a different camcorder. Or if I want to continue using my phone. I've already cracked the screen protector on my brand new phone, so my wife's not too thrilled about me using the phone, but those things happen. If you have any suggestions, please give me a shout in the comments of what I might do about recording these. Some of you may just say, just stop recording them, I don't know, but anyway, let me know. Love to hear from you. Yeah, so it's been a little regular, so please hit that notification bell too so you know when the videos are coming out. Today I'm kind of at a standstill on several of my projects here. The one that I'm not on a standstill on is the CNC plasma table, and that's what I'm going to be working on today. I'm going to be working on the last C of CNC, the control, computer numerical control. This is what I've elected to use to hold all of the electronics, basically, of the plasma table. Basically, there'll be the plasma table. There'll be a plasma machine, which I bought the other day. So I basically have got almost all of the pieces assembled to put this together and start cutting. There's the computer, and a friend of mine gave me a laptop. I've got to make sure that it's going to work. And then there's the electronics package, and that's what this is right here. I elected to go with an ammo case. It has a hinged lid so I can get to the electronics if I need to. It's probably a little bit bigger than it needs to be, but the price was right, and I figured one thing about it that I felt was important, even though this is not going to be airtight because I am going to be putting a cooling fan in it and I'll have to be putting some vents in the back, but it does have a seal around the top. So my hope is the water that from the table that might come down on top of it will run over the sides and protect what's inside from getting wet. I'm thinking that what I may do is build a stand for this that will also have the computer, a place for the laptop to sit on it. That's what I'm contemplating. I talked to JD's Garages about noise from the actual plasma cutter. They said they do have their plasma cutter about 6 feet from this equipment. Noise is a big thing with this. Electric noise, not the actual have to wear ear protection, but electrical noise. So I'm trying to decide what I want to do on that. But for right now, I know I need to get this assembled. So what I've done so far, besides cutting the hole in the front of it for the fan, is I have taken and made an aluminum mounting plate. For the major components that go in here. You've got your power unit that takes the 110 volt wall socket electricity that's made in a coal-fired power plant. And then it supplies power to the unit. This is the X-axis motor driver, this is the Y-axis motor driver, and this is the Z-axis, or Z for those of you in other countries, Z-axis motor controller. This is the Arduino, and this is the relay for the plasma unit. So Of course, the Arduino is what takes the instructions from the laptop. This is the connection for the USB cable on it, and then it supplies information to the drivers and the relay. So with that said, I'm going to go ahead and get started installing this fan. The one thing that I did on it was I went ahead, I want to keep vermin out of this if at all possible. So I cut a small piece of window screen that is the same size as the fan. And this is just a 24 volt computer fan. The idea is I want to get airflow through the box so that none of the electronics overheat. So with that, I'm going to go ahead. Oh, this is the cable. This is shielded cable. It's got a aluminized mylar sleeve, and then it has I think they call it a drain that basically makes electrical contact with it. So this is shielded with like a metal shielding that you can ground at each end, and that way electrical noise cannot or is less likely to interfere with the wire and put a signal in there that you don't want. So I've got that, and another thing that I became aware of was the fact that the Arduino has the basically breadboard jumper wires, and I went out and bought a whole bunch of them, so I've got a bunch of those for additional projects. So with that, let me get started on installing this fan. The fan comes with a metal cover to protect the fan from large pieces of junk, and then the small, and it comes with the set of mounting screws. So with that, let me get started on getting this installed. Okay, so there's the fan installed, and it would appear that I believe the cable that is with it will be long enough to reach the power supply, so I don't think I'll have to jumper it. So let me get with that done. I'm going to set this aside, and I'm going to start installing the jumpers onto the panel here. Okay, now as part of the JD's garage plan package that you get, I think it's 25 bucks. They do include the wiring diagram. Now here's the thing. Okay, I know enough about the electronics to be really, really dangerous. But basically, you don't really have to know much about anything about these things other than to put slot A into tab, or tab A into slot B, that sort of thing. Because, and the thing about JD's Garage, they didn't just design this, they actually used this unit in their business. So they have done a lot of design, electronics design, a lot of mechanical design, but it's more than just information on paper. They have actually put it all together and worked the bugs out of it. So for 25 bucks, this is sort of a no-brainer. I can't recommend this part of the JD's package enough. I mean, unless you really are a whiz at this kind of stuff and you just want to do it for the fun of it, they've already done all the hard work. I mean, uh, and it's all color coded, and if you buy this package of jumpers, you're in good shape with the colors. So it's just a matter of, like I say, slot or tab A into slot B. So now the one thing that I did do that I wish I had done differently was I've got the Z-axis controller here like this. If I had it to do over again, I don't know whether I'd flip. I could probably still flip it around, but I kind of like it installed the way it is. The problem is you can't get to the screws to tighten the wires into it. So what you have to do is, if you're going to be doing any work on it, you have to take, on mine anyway, you have to take the Z-axis controller out. And it's just really, I've got it set up, you take out the one screw and nut, and it slides out just like that. So, and also, since I have done it this way, some things, the Z-axis motor are the ends of the runs. For me, they have to be the beginning of the runs, or vice versa. I think they're the beginning of the runs, and I have to make them the end of the run. But we're going to start with the 24 volt positive, and then I'm going to shut up and just play some music while I do this wiring, because as my wife said, it's sort of like watching paint dry. Okay, so with that, everything is hooked up except the wires that go to the motors and the fan and then the power supply from outside. So I think what I'm going to do now is I'm going to stop, check the time. I may go eat lunch and come back and figure out how I'm going to do the motor control wires. So let me pause this. Okay, so what I'm going to do now is lay out a grid, and I'm going to take a 16th inch drill bit and put holes in the ammo crate, and I'm going to try and drill them at an angle going up into the box, so that if it should get water splashed on it, hopefully it'll shed the water. If I find out I'm getting moisture in the box, what I will probably do then is build a shield that will go over this. But I'm going to be putting a lot of holes in it. Small ones, 1/16 of an inch holes. And like I said, I'm going to try and hold the drill at a 45-degree angle. So let me get this laid out and I will start drilling. Okay, so it's a new day here at Chopper Bob Customs, and I stopped videoing yesterday. I came to, first off, when you're doing this type of thing, the JD's Garage's plans are great. It shows you exactly how to wire all this up so it's going to work, but they don't show you how to put it all together. And in some respects that's good, in some respects it's bad. Basically what it boils down to is you're going to have to be designing, and since you're kind of mixing and matching parts, you don't know where the holes are supposed to go, all of this and that, you're designing on the fly. And the truth of the matter is, like, I've been soldering since I was a teenager. That's decades ago. Drilling holes, probably longer than that. You know, doing wiring. I've had toy trains and slot cars and everything, so I've been around that for longer than I care to admit. So all of that stuff is kind of good, and I've done design work. I mean, you know, but the issue on this is that one, you don't have a lot of information, and two, you kind of have to design on the fly. So with that being said, what happened yesterday was I kind of stopped videoing when I was drilling holes, and I'm going to have to see how I can edit it so that I eliminate some of that, because I started drilling the holes and I'm thinking, oh my goodness, this is going to take forever. And then I thought, you know what, maybe you better double check your math and make sure that the holes were going to be sufficient. And what I found out was that the number of holes that I had laid out was about 1/4 of the number of holes I would have needed. And I decided then and there that I wasn't going to continue on with it. So what I did was I did go ahead with screen on a larger opening. The reason that I didn't want to use screen to begin with was, one, I was thinking that the holes would be better at keeping water out of the system. Two, it might be a little bit cleaner. I know that the screen has a tendency to collect dust and other debris, so you're going to have to be constantly aware of it and keep it clean. And three, this plastic, this engineered plastic, the sort of rubberized, flexible plastic, doesn't do a great job of accepting adhesives. With that being said, I finally decided that that I can come up with another way of keeping water from entering the system. I'll just have to be cognizant that I need to keep it clean. Probably have an air duster out here for like a computer, which I probably should have for the computer as well, so that's sort of not an issue. And then what I did was I took my 100-watt soldering iron and basically melted the aluminum screen into the container. And so what I've ended up with is a large opening right here that's protected with the screen to keep vermin out of it, and it is basically melded into the side of the housing, which should supply more than enough surface area to match the surface area of the outflow from the fan. And then since the controllers were all wired up, I did decide to make a a connector. Let me see if I can show it to you here. For the fan, so that in case I did need to service it, I can just unplug it. Basically, I took a couple of the breadboard connectors, used a shrink tube on it to shrink them together, and it plugs into the connector that comes with the fan. The only thing that you need to be aware of on this is that you need to match red to red and black to black so that the polarity is correct and it actually draws air through instead of pushing air into the housing. With that, then I decided to go ahead and start making the connections for the stepper motors. I've got 5 units. This one right here, I'm not exactly sure what I'm going to do with yet. I've got to do some research on the automatic height control that I will probably be adding to this for the Z-axis. But I'll have the X-axis motor, the Y-axis motor, the Z-axis motor, and then this is for rotary action that I will hopefully add at some point in time down the road. So I'm going to go ahead and wire it up now because it actually wires up to the X controller. Now, I went out online and also looked at shielded cable. Now, JD's Garage recommends shielded cable. Some guys say, oh, you don't need it on your stepper motors. I didn't find anything that said that it was detrimental. So my rule of thumb is, unless there is a detriment, if I have one person saying do it and another person saying don't do it, I tend to err on doing it just to be safe. If there's detrimental effects, I review them and make an informed decision after the fact. But right now, I could not find anything that said don't use shielded cable. If you're not familiar with shielded cable, let me show you what I'm using. This is recommended by JD's Garage. You get the plans, the information on where to order this is in the plans. But basically, it has either a synthetic or some form of very flexible covering on the outside of it. There you can, I think you can see that it has this external covering. And when you cut it away, what you will find is a wire mesh that basically wraps around on the inside of this sleeve. And then inside of that is this aluminized mylar. I believe it's mylar. If it's not mylar, somebody knows what this actually is, let me know in the comments. But basically, I do know that on the side that is in contact with this wire mesh, it is conductive on this side, and it is not conductive on this side. Okay, so what happens is that it goes the entire length. It's wrapped all the way around all the cables that are in it, and then this wire mesh is in constant contact with this. I believe this is called the drain, and this is actually the shield. Okay, what you want to do is you want to ground this, and we'll get into that a little bit later. And then this is a 4 conductor. It's got a red, a black, white, and a yellow. And then it's got these annoying but important fiber, I think it's got 5 of them, cords that go through here. And what that does is that just gives it strength laterally so that when you're pulling on it, you're actually pulling on these fiber cords. And at the end where you're working on this, you have to cut them off and dispose of them. And then I usually fold this down a little bit and then trim it back so it's not a lot. And then you can solder a ground wire to this connector here, shrink tube it. And what I've done so far is I've built the X-axis cable, and I've built the Z-axis cable. There's the Z-axis. Okay. And basically what you do is you solder the the connectors, and I got the 5-pin because I just wanted to run the ground through to this side over here, so that, oh, there, let me get that. The ground, the drain wire comes in here, and then it'll come out of here to the stepper motor, where you'll ground it to the frame of the stepper motor. And then at this end, that will have a wire connected to it that will go to the ground, and then these will go to the controller. Okay. Now, I also decided that since this was a plastic case, and since I'm being rather fastidious about grounding it, what I did was I made a thin aluminum panel. This was actually my drilling guide to start with, to drill the holes in the side of the box, and it's got a little tab here that I will be able to run a ground wire to the ground, the common ground that I have in the system, and then this will ground all of the housings of the 5-pin connector. And of course, the 5-pin connector, you unscrew the thumb screw here, and when it's off, you simply unplug it, and you've got 5 pins, so that when you plug it back together, it makes contact, and that way you can disconnect this box from the stepper motors for storage. That's the primary reason I did it. So with that said, I'm going to go ahead and start building the Y-axis unit. And in hindsight, the first ones I built, the drain, I went ahead and used the black wire because I'm not sure that I actually have any green wire that is thin enough for this assembly. I've got some green wire, but I believe it's 18 gauge, and this really functions better if you're using 20 or 22 gauge. So I'm going to go ahead and do it that way. Let me reposition the camera here. And I'm going to speed this up because you've probably seen people solder before, but I'll just kind of go through one assembling it. Hopefully I won't make a fool of myself. I left a good gap there so that if I need to edit it out, I can. Okay, so, and I've also determined that I probably need a new set of, I hate doing this because these were made in the USA. And I've had these since, probably I've had these for at least 45 years. But there's, and I don't know whether I think I've already tightened them up a couple of times. These are by Vaco. I'm gonna have to check and see if they still make them in the United States. I mean, these things have held up great. They they do crimping. They put a nice crimp in crimp connectors. It's got a small bolt cutter right here so that you can screw the bolt in, cut it off to length, and then take it out so that if the threads are damaged, it'll basically re-thread them coming out. And then it's got 22 gauge wire to 10 gauge wire. The wire cutter portion of it basically stopped working a long time ago. It just got flat wore out. But now it's got flexibility this way, and it makes it a little bit hard to strip wires. But what I generally do is I figure out how much I need to strip. I rock it back and forth, and then give it a quarter turn and rock it back and forth again, and it strips. So there we go. And so now I will shut up and just work and speed this up. Okay, so with that, I've got the end prep ready to go. I've got the shielding trim back, it's folded over the top. I've got the drain wire twisted together. I've got the ends of the 4 cables trimmed back so that they will slide into the receivers on the 5-pin connector, and I've trimmed off the fiber pieces so that they're not in the way. So now, what I do to make this easy on myself is I will take and mount this in one of the holes and orient it so that I can work on it. This just sort of makes it easier. It sort of acts like another hand because it's kind of hard to juggle all of this. And then I give it an anchor. Okay, and then I want to be consistent. So basically that's one of the reasons why I have the other one out here, is that basically I've been going red on number 1, yellow on number 2, white on number 3, the black cable on number 4, and then the drain is on number 5. Part of the reason I want to be that way is that the stepper motors, well, they have the red and the black. I think the other 2 wires are blue and green instead of white and yellow. And so I just kind of want to make sure that I've got that oriented in such a way that I don't have to be individually making each one different. I can basically just follow along and make sure that it's correct. And then, so the first thing I'm going to do is twist the drain wire to the piece of wire that I'm going to be using to extend it and make it so that it will actually fit in the 5-pin, and then trim it to length. The other thing that I will do is I will install a heat sink, because I really don't want the solder going up the cable, because I want it to be as flexible as possible. Heat sink in there, making sure that the wires don't unwrap. Now, the one thing that I do use is Tix Flux. This is a really nice flux, and what you're going to see me do is what you shouldn't do when you're soldering, but on tight things like this, I just cannot see my way clear to do it correctly, in that I will take and load the tip up and transfer from the tip to the wire. And the Tix Flux lets you get away with this. I mean, it really flows out well. Let's see if I fingers. I mean, it flows out so well that that's one of the reasons why I put the heat sink on there, to keep flux from going up into, or solder from following the flux up into the wire that I've made here. And then now, once I go to install it into the 5-pin, I'm not that concerned if it's not flexible anymore. But what I want right now is I want a flexible wire. And so I will cut this to length. I'll pull the rest of these up here and figure where I need to cut my wire. Okay. And strip it. Okay, now, and again, the reason I have this up here is because I want to make sure that I'm doing it exactly the same. And I start with, you're going to have to develop your own procedure for this, but because the number 3 is down at the bottom and kind of shielded from both directions, I will start with it and then work my way up on either side. Okay, so now here's an example of designing on the fly, or change order, I guess it would be, during fabrication. I wanted to protect this with shrink tube. I really would have liked to have individually shrink tubed them, but I didn't see any way possible to do that with soldering. If I had it slid back far enough, I would have stripped too much of it off. I wanted this to be really close in here. I probably could have stripped it back further and used the longer ground wire, but I didn't want to have more exposed than that. And so I was using a 2 shrink tube program where I did one shrink to kind of tie all of this drain stuff out of the way, and then I used a larger one over the entire assembly. And what I ran into was the fact that the larger one over the entire assembly pulled back away from the pins. And so I'm going to be trying a 3 tube on this, where I basically I'm just covering the pins, and I'm going to see if this gives me a better coverage of the pins so that they are not uncovered. Okay, I like that better. It brings the protection up further on those pins than what I was getting before. My concern there is I just don't want any debris to get down there and make contact with the pins and possibly short two of them out. But here you can see I've got the red, yellow, white, black, and then I'm using a black for the, but keep this in frame. Red, yellow, white, black, and then the black that I'm using for the drain right there. So there's the X one. I'm probably not going to video the rotary one. It's lunchtime. I'm going to go eat lunch. So, but that's basically how I'm doing that end. I will come back and show you how I'm going to do the other end on it, and probably the motor hookup ones as well. Okay, so I've gone ahead and done the controller end of, this is the rotary one, but they're basically all four the same. You've got the rotary, which shares the controller with the X-axis motor. You've got the Y-axis motor, and you got the Z-axis motor, Z-axis motor. Anyway, so basically what I did was I cut to length a small pigtail that will go under the one of the hold down bolts for the controller, and it'll have a star washer to make sure it's got good bite, good ground to the frame, and it's soldered to the drain, so the drain will have a good ground to the other end. I also went ahead and prepped the ends so that they will go into the controller. And I've gone ahead and tinned them. I don't know whether you can see that or not. Basically, that's so the clamp that's in there won't shear off individual strands. These are very fine strands. So basically, all four of them are ready to go in. I've got a few more things I've got to pick up. I'm going to make a run right now. But when I get back, I'll go ahead and hopefully get this box wrapped up. One of the things that I think I'm going to do to all of them, I didn't like the way the clear looked on this. This is up where you can see it right at in the box. I'm probably the only one that'll ever see it, but to me, it just didn't have a finished look. And so I've gone ahead and put black shrink wrap on it. Let me know in the comments. You think I should leave them alone or dress them up like this? Anyway, yeah, let me make a run, and I'll go ahead and hopefully get this box finished up here in just a couple minutes. More like a couple hours. Okay, so I think we're in the home stretch on the control box. So, for one thing I did real quick was I checked to make sure that on the right side of the power unit, there's the line, the neutral, and the ground for the wires coming in from the 110 outlet. And when I checked the ground, what I found is that it is actually grounded to the case. However, the oxide layer on the aluminum, you have to scratch through it in order to get it. And it's relying on four tiny little, I think they're M4s or M3 screws holding it to this frame that I've got everything mounted on. So what I'm going to do is I made a jumper that is going to go on the negative terminal, or I'm sorry, not the negative, the ground terminal here with the ground from the power cord. And then I'm going to find a place where I can put another eyelet on the end of it and ground it to the actual chassis of this unit. So that's one thing that I've done. And then for the power supply, what I did was I went out and I bought, I wanted some flexibility so that I could position this where I needed to in the shop and I didn't have to worry about having an extension cord or something like that. I wanted to hook it up directly to an outlet in the shop. And so I went and bought a 25-foot 13 amp. It's a 16 gauge wire, 3 conductor. I think they call it 3-conductor because the ground actually is insulated. So you've got your black for your line, you've got your white for your neutral, and then you've got your green for your ground. 3-prong outlet. And then I've gone ahead and I've installed it in the box with a strain relief. This is a weatherproof strain relief, so moisture and so forth can't, dust and everything else can't get in through there. I've got other places for the moisture and the dust to get in through now. But so what I'm going to do now is I'm going to put some ring terminals on it, if I can find them since I knocked them off the bench. And we'll get the power hooked up. Okay, so that's ready to hook up. The other thing that will need to be run through here will be the USB cable that will connect the computer at this end to the Arduino at this end. And if I've sized this correctly, got a strain relief for it, and I'll need to see what size hole I need to drill for this strain relief. And then I'm also going to have to find some way to make this fit. I think what I decided was, yeah, I think that'll work. Okay, the deal here is, in order to get this strain relief on here, to get around this USB plug, which is the smaller of the two, I had to go with a larger strain relief. And so what I'm going to do is, I've got a piece of vacuum tube, rather thick wall, that I'm going to split lengthwise. And see if it won't fit around the cable. Will fit in the and that makes a it could probably be a little bit better on being watertight, but I can see just a tiny speck of daylight in there, but on the whole, and then it does also act as a strain relief. So it's not going to pull on the Arduino if the cable gets pulled a little bit. So let me go get a drill bit. I need to get a larger drill bit than what I've got checked up. And then finally, and I think this is the last little bit other than making the connection for the ground from the power unit to the chassis. The fifth 5-pin connector. Okay, so the Lotus CNC plasma unit that JD's Garages uses and sort of recommends. Their build is kind of centered around it. Has a 2-pin connector on the back and a 4-pin connector on the back, and the relay that tells the Arduino tells the relay to send power to the plasma cutter to say turn the arc on, turn the arc off. And so there's a common and a normally open that goes to pins number 1 and number 2 on the 4-pin connector on the Lotus. Now the other 2 pins and then the 2-pin connector, I believe that 2 of those are for voltage feedback, so that if you have a Z-axis controller based on the voltage, so if the voltage isn't correct for the cutting, the Z-axis will actually move the torch head up and down depending on what the feedback voltage is to get a more perfect cut. And assuming I get all this together and it all works the way it's supposed to, I eventually want to go with a Z-axis controller based on voltage. So what I'm going to go ahead and do is I'm going to go ahead and set up a shielded cable using only 2 of the 4 wires in it. And then that way I'll have room for the expansion if I need to put in that controller running 2. I'm assuming it's 2 wires. I could be wrong, but I figure this way at least I'll have 4 wires going to the plasma cutter, so that I can get that voltage feedback if that is the way it's actually going to work. So I'm going to go ahead and get that set up right now. And you've seen me do these. It's basically going to be almost identical to the other ones that I've done already, and so I'm just not going to record it. If you, I don't think it's good. It's not a good use of time on the recording. So I'm going to go ahead and shut this off now. And when I come back, I'll basically be assembling everything in the box. I hope. Fingers crossed. Okay, so I'll get that wire fixed up and then this will be ready to go. I think we'll call it quits on this video for now. I think the next time I'll be working on it, I'll probably either be hooking the cables up to the motors, or I'll be building the water pan. get the water pan built, and then get the slats made or bought for it, and then get the computer set up so that I can do the drafting and the CAD, the cam, and then the controls, and then I should be ready to start cutting. So I've got some plans of the first parts I need to make for another project that's coming up I keep telling you about, which leads me into you need to hit that notification bell so you know when the videos are coming up. If you haven't subscribed already, please consider doing so. I've got a lot of people watching the videos now, and I've got some in the thousands, which has taken a while to get there. But if you're not a subscriber, if you are a subscriber, thank you very much for subscribing. If you're not a subscriber, please consider doing it. I'd appreciate it if you'd like the videos, and if you got any comments, questions, want to know how it's going on, just leave them there. Like I said, if it's a question, I'll try and get back to you really promptly. If it's a comment that I need to respond to, I'll get back to it promptly. Like to hear from you. If you got any ideas on how to do this stuff better, I would be interested in hearing it. But for now, Chopper Bob out.